Okay, now we're going to put it all together and see if we can graph some rational functions. And so when I say examples of graphing rational functions, I mean at least one. We'll see how time allows here. So we'll start with this one, and we'll look at where this clearly there's some x values that stand out, right? If x is -3, the function is 0. So let's set up a number line here maybe first. So we'll set up our x values, and then up here we'll have our y values. Okay, so we've got -3, 4, 0, and 2. So let's see, -3, 0, 2, and 4. Those are the things that make each of these 0. Let's see what happens. If x is -3, the numerator is 0, which 0 divided by anything is 0. So at -3, y is 0. If x is 0, we get 0 in the denominator, which is undefined. Okay? If x is 2, we get 0 in the denominator, so it's undefined again. If x is 4, we get 0 in the numerator, and 0 divided by a number is 0. So if x is 4, y is 0. So I hope you see that these are all y values up here, and then these are our x values down here. Okay, great. Now what we could do maybe is look at the ends of this function to determine if the ends here are positive or negative. The ends of the function are determined by, as x gets big, so let's label this ends. As x gets big, y gets close to the leading term on top divided by the leading term on bottom. The leading term on top is x squared, and on bottom it's x cubed, which simplifies to 1 over x, and 1 over x looks like this, approaches the x-axis from the top, approaches the x-axis from the bottom. So the right end, y, is positive because it's above the x-axis. The left end, y, is negative because it's below the x-axis. Okay, great. And we know what our ends look like when we actually go to graph this function. This is all simply figuring out when y is negative, positive, 0, or undefined. Okay, so now we can use our multiplicities or the exponents. So x plus 3 is to the first, x minus 4 is to the first, x minus 2 is to the first, and x is squared. So I have a negative sign here. When I cross -3, that came from this guy, which is raised to an odd power. So when I cross over -3, I have an odd number of sign changes, which changes this negative to a positive. When I cross over 0, that comes from the x squared, which has an even number of sign changes, so the sign is the same as it was before. Cross over 2, that comes from x minus 2 to the first, which is an odd exponent, or odd multiplicity, which makes this change to a negative. When I cross over 4, 4 came from x minus 4 to the first, which is an odd exponent, so my sign changes from negative to positive, and see how it all matches. So that's good, everything matched up like we expected. Now let's see if we can start to graph this, okay? So I'll line this up where x is 0, that's going to be my y-axis. Here's my -3, I'll line that up here. Here's my 2, I'll line that up, and here's my 4. So at x being -3, y is 0, so I have an ordered pair, -3, 0. And the same thing at 4, y is 0. At x equals 0, my function is undefined, so I'll sort of draw on this vertical dashed line, and it may be an asymptote, we'll see. And the same thing at 2. And I also know the ends of my graph have to approach the x-axis from the top and the x-axis from the bottom. So I go to the last thing I have on my picture here on the right, which is this point, and then from here on, this is the rightmost part that I have, I need to somehow make this happen and stay above the x-axis because my function is positive after 4. So I have to go above the x-axis, and then at some point I have to drop back down and approach the x-axis. Okay? On the left side, I do the same thing. The last part that I know is I have this -3. That's a point. I have to touch it. Then to the left of -3, I have to be below the x-axis because y is negative, and I have to approach the x-axis eventually as I go left. So I have to drop below, and then I have to come back up and approach my x-axis. So I have my ends graphed. Now the question is, what happens near these values of 0 and 2? Well, if x is 0, or if x is approaching 0, my denominator approaches 0. And so if I take a number and divide it by something really small, I get a really big y value. Y is big, and it could be positive or negative. Okay? Well, on the left side of 0, here's 0, right? And the x is approaching 0. Well, I can see on both sides of 0 my function's positive. But when x is close to 0, y is big. So I'm a positive big number on each side. So when I'm close to 0 from the left, my y values have to get big like this. And when I'm close to 0 from the right, my y values have to get big like that. Good. So this is a vertical asymptote at x equals 0. Now, at x equals 2, or as x gets close to 2, my denominator gets close to 0, so y gets big again. But to the left of 2 I'm positive, so I'm a positive big number to the left of 2. And to the right of 2 I'm negative, but again, when I'm close to 2, my denominator's very small, so the whole fraction is very big. So I have a negative really big number, so I'm going to have something like this. Okay, now all I have to do is connect all the pieces that I can. So all I know in this region here between -3 and 0 is I have this point, and I know my function has to do this, so I just connect them. Something like that. If you want to know precisely what the y values are between here, plug in some numbers between 0 and -3, and you can calculate them. Here we're just going for a sketch of the graph though. Alright, from 0 to 2, all I have are these two pieces. Now, you have some options here. You know they connect, but can you do this sort of thing? That would be a good question. And the answer is no, because I can't cross the x-axis here. I have to stay above the x-axis because my y's are positive. So all I can do is connect those two pieces somewhere above the x-axis, so maybe like that. Again, if you want to know the y values here, plug in some numbers between 0 and 2 and get a better idea. Now from 2 to 4, I have this point, and I have this part of the curve. I also know I have to be negative, so this entire region has to be below the x-axis, so I'll just connect those pieces. And this is a sketch of the graph of this function. We use where it's 0, we used where it's undefined, we used where it's positive, negative, and then we looked at what happens to y whenever I get close to those values where it's undefined. We also looked at the ends of the graph by looking at the leading term. Now this may seem overwhelming, but once you practice this a few times it gets really fast. Okay, so a big part of this is this number line idea, determining where it's positive and negative. And then you just basically approach all your asymptotes and get your ends right, and you're there. So, as I said, at least one example. Well, there we go. There's our one example. I'm running out of time here, so I don't have any other time for any other examples. However, I will mention one thing, that this function was factored. Again, that's very useful because that's what quickly tells us if it's positive or negative. Okay? And it also tells us where the numerator equals 0 and where the denominator equals 0, so that we know when the function is 0 or undefined.